Welcome to Making and Treating of Steels course. Today I am going to talk about the main principle of electric arc furnace based steel making and how this process of making steel is happening in this route, and finally it will be compared between LD converter, which was oxygen based steel making, and this is electric arc based steel making. What are the advantages, disadvantages, what is the route, and what is the process difference will be emphasized lastly in this lecture. In a previous lecture I was talking about mainly electric arc furnace design and refractory materials used, construction, and what are the principle of lifting mechanism was adapted in this route, and how do you calculate the power consumption heat produced by this route is emphasized and explained clearly. Today I am going to talk about what is the principle mainly involved in this is electric arc is allowed to form in between the metal charge which was poured here and the electrode arc, and so that the electric arc radiation develops. The radiation slowly heats up, and that particular heat build up rise to a temperature to melt the corresponding charge, such as steel. It will reach to, if it is reached to the around 1600 degrees Celsius temperature, meltdown starts. So after meltdown starts, you will take out the slag layer to be removed from one side, and finally you will take out hot metal steel removed from another tap hole. And there are two principles which involves in this electric arc furnace route are, one is alternative current based and the other thing is direct current based. The basic difference is, in the case of alternative current, the current flows from electrode to directly to charge. In between the radiation is evolving. And when you come for the direct current, the current flows from this graphite electrode to the bottom anode material, which was based on the charge material. It is been chosen from the anode. It is generated in between this anode and cathode. One need to notice this. This is the control panel of operating electrical energy based for the DC furnace, for AC furnace. Make a note that the 3-phase AC current is sufficient for using the melting through electric arc furnace. There are things called as a VCB, voltage current breakers, and thyristor and transistor, transformer, high frequency filter. These all things helps that controlling the temperature and melting stage. So all those things are helpful. This is the electrical room. Now coming to the next point, that now I am going to talk about the charge materials or the steps involved in electric arc furnace based steel making. First you need to collect the charge material, whether it could be the steel scrap only, whether it could be combination of steel scrap and liquid pig iron, or it could be the ferroalloy based steel making, it could be the stainless steel production process, or it could be the sponge iron based steel making, or sponge iron combination of liquid pig iron. All those things first it need to be collected for the based on the capacity of that electric arc furnace. Then after that particular charge material is feeded into the electric arc furnace, such as steel scrap and sponge iron, start arc producing in between AC based furnace or DC based furnace, and melting starts. Refining within the furnace will takes place as the time proceeds. Arc radiation evolves once it reaches to the melting stage within the liquid steel due to the chemical energy, heat evolving or heat absorption and chemical reactions between these molecules and atoms takes place. Refining will occur, and refining mainly includes the following operations. First, if you are using the oxidizing based slag only or scrap, the oxidizing slag is removed. Then after the slag removal is switched off, and make single reducing slag for the removal of sulfur. The oxidizing slag is for the removal of phosphorus. This is for the removal of sulfur, and tap out that particular reducing slag and stop the slag. After, there will be 1 hour difference between these two operations. Finally, this slag is removed completely. Then you go for tapping of hot metal steel. Okay, and the classification of, let us know, it is important to know about the classification of raw materials used in electric arc furnace, because it can produce variety of steels. When you compare with the LD converter, you can maximum extent you can produce alloy steel or plain carbon steel. This electrical arc furnace is quite in practice for producing variety of steels. There will be a scrap based on the oxidizing elements such as aluminum, silicon. These things will be immediately get oxidized. You will take out a single oxidizing slag, phosphorus will be removed, and you will take out the hot metal steel. That is one step of steel production. The other thing is partially oxidizing elements, phosphorus, chromium, manganese, etc. And those slag will be removed and taken out the molten steel. And scrap based volatile elements such as zinc, cadmium and lead, and scrap based non-oxidizing elements copper, nickel, molybdenum, arsenic, tungsten, where the reducing slag stage takes place. Mainly the sulfur will be reduced to some extent, and there will be another base steel making process within the electric arc furnace which was practiced, sponge iron combination of liquid pig iron, or only sponge iron based steel making, or ferroalloy based steel making. You will use ferrochrome, ferromanganese such as alloys, and you produce the steel, and those are the advantages. Let us know about the melting process of how the melting step takes place. Initially, the electrodes are lowered slowly with the mechanical motors and bored into the charged material. It could be the steel scrap, sponge iron, depending upon the charged material chosen. The voltage is selected first lower voltages, and to protect the roof. Initially there will be sparks generation, it's waves of the roof. Slowly you increase the voltage, and these are the damage. For protecting all these things, you choose low voltage. Once arc is generated, the melting stage is started. Slowly the voltage is increased, so that molten metal pool will be increased. Depending upon that, oxidizing slag will be removed and reducing slag will be removed based on the charged material used. Then after refining studies observed, at the melting stage, initially this iron, silicon, manganese start oxidizing, so that particular slag will be removed, and if lime is added, oxidizing slag immediately forms. And at the carbon boil stage, the carbon will be in the range of 0.15 to 0.3, which is medium carbon steel, and some oxygen will be dissolved in the steel. And then after you go for the reducing slag. After this oxidizing slag, these things takes place in the refining stage. Coming to there are various types of slag practice to produce types of steels. Which type of slag practice? For example, if single oxidizing slag is practiced, it means that plain carbon steels and low alloy steels are produced. To produce these things, you prefer this slag route, and to produce the ILS steels, you choose reducing slag mode, single reducing slag mode. If you want to produce low phosphorus based steel based on the requirement of client and industries based on its application, you go for the double oxidizing slag. And if oxidizing slag after the reducing slag is followed, it is removed phosphorus as well as the sulfur at the melting stage itself, not going to the refining stage. So this is one more advantage. If oxidizing slag is converted into the reducing slag, it is usually in the practice of to produce the stainless steel. You will be adding the chromium and nickel. The sulfur will be mainly reduced. Sulfur need to be removed in the stainless steel. So in that situation, this slag practice route is preferred. And flush slag practice, the refining of oxidizing slag and reducing slag will be done separately, mainly to remove the sulfur to further extent. Oxidizing slag is removed initially, then after deoxidation of both is allowed to takes place, and addition of CaO is added some amount of, and coke. This ratio is maintained 6:1 or 12:1. These are the chemical reactions which takes place so that sulfur will be removed off, for especially for the stainless steel production process. How do you calculate annual capacity of that particular electric arc furnace? It depends upon, you use this particular formula, A is equal to 24 Nmy by 100T, where small n is number of working days, M is stands for mass of the metallic charge used for producing the steel, and yield, iron yield, how much iron was contained in the metallic charge, and T is the tap to tap time, 1 8 to another 8, how much time was taking place. For example, 50 minutes time one tap, another 15 minutes time another one. So what is the difference? This particular tap time is depends upon the charging time, how much amount of time took place for charging of the raw material, entire raw material I mean, and meltdown time, how much time is allowed to melt down to takes place by the arc radiation, and refining also, which includes oxidation period and reducing period. And finally, conclusion about the electric arc furnace is that, what is the source of energy used in electric arc furnace? Oxygen steel making, such as LD converter steel making. The source of energy in the case of EF is electrical energy and chemical energy. In the case of oxygen steel making, it is chemical energy. And electrical arc furnace, iron containing raw material such as hot metal, liquid pig iron, or sponge iron, scrap you may be using depending upon the material available. In the case of oxygen steel making, hot metal or 20 to 30% of scrap combination is preferred to use in the case of oxygen steel making. Liquid pig iron and 20 to 30% of steel scrap is allowed. This scrap is nothing but steel scrap. Operating procedure main principle, main step is, the slag forming is continuously shielded for the electric arc during the electric arc furnace. It protects the refractory lining of EAF process, and oxygen supply is continuously maintained to refine the hot metal here. This is the main principle in the case of oxygen steel making. Thank you.